Hello my dear friends, welcome back. Let us continue with now exercise 7.5. 7.5, let's continue with question number 11. So the question number 11, it's integral of 5x divided by x plus 1 x square minus 4 with respect to x. So let's first solve this. Let's first take out this function x plus 1 x square minus 4. So this can be written as 5x x plus 1 x square minus 4 is 2 square, so x square minus 2 square, x square minus 2 square, so that's a square minus b square, so that can be just written as a plus b into a minus b. So now we shall solve this. So let 5x by x plus 1 x plus 2 x minus 2, let this be equal to, as we have already done before, a by x plus 1 plus b by x plus 2 plus c by x minus 2. Now let's simplify this and find out the constant terms. So let's take the LCM. Let this be our equation 1 because we will need this. So taking the common LCM, that is x plus 1 x plus 2 x minus 2, so that's a into x plus 2 x minus 2 plus b into x plus 1 x minus 2 plus c into x plus 1 x plus 2. So cancelling the denominator on both the sides, we have 5x is equal to a x plus 2 x minus 2 plus b x plus 1 x minus 2 plus c x plus 1 x plus 2. So now let's solve this. Now we can either go for finding out the coefficients, solving this and comparing the coefficients, or there is another way to solve this. Okay, so let's try the other way this time. Alright, so we'll try both the ways. You can just choose which one is convenient for you, and accordingly you can solve. So I've solved in the previous exercises videos also, so you can check out both. I'll be doing by both of them so that you can see which one is more convenient for you. So now since here all the terms are quite different but after taking the LCM, so we can adopt this procedure that we are going to apply now. That is, let this be just a normal equation for us, another equation, okay, a. So we are going to use this. So one by one let's solve. See, our main priority is just to find out the constant terms, a, b and c. So no matter how you simplify it, if you do it mathematically correct, doesn't matter, as long as you do it mathematically correct, I mean. So let's say putting x equal to, so what I'll do here is, if I want to find out the term a, so if I can just make these terms b and c disappear by putting a particular value of x, which I can here, because if I put x equal to minus 1, you see what happens. Then it's f into minus 1, that's equal to minus 1 plus 2 minus 1 minus 2, plus this becomes b, minus 1 plus 1 0, and this also becomes minus 1 plus 1 0. So we'll have the term only a, so that's a into 1 into minus 3. So we shall have minus 5 by minus 3 as a, that is a equal to 5 by 3. Alright, similarly, next you focus on now the value of b. So if I can make these two terms disappear, so we have plus 2 here, x plus 2. If I can just put minus 2 becomes 0, doesn't affect this value. So x as minus 2, so 5 into minus 2, that's equal to a, so I'll just write this as 0. b minus 2 plus 1 minus 2 plus, this is also 0 because minus 2 plus 2 0. So that's minus 10, that's equal to b minus 1 into minus 4. So minus 10 by 4 will be the value of b, or in other words, minus 5 by 2 shall be the value of b. I'll just solve it here, okay? So then next, putting x equal to, now focus on c. So I have in mind x minus 2, x minus 2. If I can just put x as 2, 0, 0, this will not be 0. So that's 5 into 2, that's equal to 0 plus c, 2 plus 1, 2 plus 2. So that's 10 divided by c in 3 into 4. So 10 by 12 equal to c, or c is 5 upon 6. I think that's clear. 5 by 6. All right, so we have our values, the constant terms a, b and c. So let's go back to question 1 now. So from 1, 5x by x plus 1, x plus 2, don't change the order, okay? You should maintain whatever order you started with, all right? Otherwise it will create some problems, okay? So a value, how much did we get? 5 by 3. 5 by 3 divided by x plus 1, plus b value we got minus 5 by 2, x plus 2, and c value we have got 5 by 6, that is x minus 2. So therefore our value of integral will be the integration of this function, isn't it? So I'll do it directly because we've already done some questions. X plus 1 with respect to x, plus minus minus 5 by 2, integration of 1 by x plus 2 with respect to x, plus 5 by 6 integral of x minus 2 with respect to x. So that's going to be 5 by 3 log of x plus 1 minus 5 by 2 log of x plus 2 plus 5 by 6 log of x minus 2 plus c. All right, so it's as simple as that. All right, okay, so let's move on to now question number 12. That is integral of x cube plus x plus 1 divided by x square minus 1 with respect to x. So if you remember, last class I told you, previous classes, in the previous exercises I told you that whenever you go for integration, whenever the power of the numerator, degree of the numerator is higher or equal to the degree of the denominator, what shall we do first? We shall divide first. Okay, x cubed by x plus 1 divided by x square minus 1. So in rational algebraic functions, okay, if the degree of the numerator is greater than or equal to the degree of the denominator, then always divide the numerator by the denominator and we will use the result. Okay, then what happens is we can convert the given integrand into the simple form, into a very simple form, and then we can integrate it very easily. Okay, so let's divide. So that's x, so that is x cube minus x. Division, I hope you know, we have already done in lower classes, plus 1. So that can be written as, integral can be written as divisor plus remainder, quotient plus remainder divided by denominator, x cube plus x plus 1. So this result is integral of x plus integral of 2x plus 1 divided by x cube plus x plus 1 with respect to, x square minus 1. What did I write? X square minus 1. Okay, so let this be question 1. We will come back and solve this later on. So now what we will do is I will take out this value, that is 2x plus 1. This one we can integrate it very easily, isn't it? So we can come back and integrate this later on. We'll now solve this. So this can be written as 2x plus 1 divided by x plus 1 into x minus 1. All right, So let's mark this as our second equation. So let's simplify this. So let 2x plus 1 divided by x plus 1 into x minus 1 equal to a by, this is also non-repeating, b by x minus 1. Let this be equation 2. So many cancellations, sorry. So now solving this, taking the LCM, removing the LCM, class 12 standard, I guess we can do this directly, b into x plus 1. So in this process also, well, let's mark this as equation 3. In this process also, we can adopt this previous method that we have used. So putting x equal to, if I want a, I need to remove b. So x equal to minus 1 in equation 3, what will I have? 2 into minus 1 plus 1 equal to a into minus 1 plus b into minus 1 plus 1, 0. So that's minus 2 plus 1 equal to a into minus 2. So that's minus 1 equal to minus 2a. So a equal to 1 by 2. I'll just do it here. Next, I shall focus on the value of a. I mean b. So putting x equal to 1, we shall have 2 into 1 plus 1 equal to 0 plus b into 1 plus 1. 2 1s are 2 plus 1, 3 divided by 2b, sorry, equal to 2b. So b equal to 3 by 2. Simple as that. Alright, so now that's it. Job done. We can now go to equation 1. So what was our equation 1? क्या यार आज क्या हो गया? So equation 2 implies, equation 2 was 2x plus 1, x plus 1 into x minus 1. What was the value of a that we have got? 1 by 2 divided by x plus 1 plus value of b 3 by 2 divided by x minus 1. Therefore, from equation 1, what do we have? The integral value as integral of x with respect to x plus integral of 2x plus 1 divided by x square minus 1 with respect to x. So this can be simply written as integral of x plus integral of, this value is this, I'll just do it, 1 by 2 into 1 by x plus 1 with respect to x plus integral of 3 by 2 1 by x minus 1 with respect to x. I hope you have understood this, isn't it? I did not write down the unnecessary steps. So integral this x square by 2, integral of this 1 by 2 into log of x plus 1, integral of this 3 by 2 into log of x minus 1 plus c. Okay, simple integration, that's why, no, once we just divide, that's it, job done. All right, question number 13. Our value of integral is, we have to integrate 2 by 1 minus x 1 plus x square. Okay, we have a quadratic form here, no problem. I had already given it to you in the previous video, so you can kindly check. So what do we do? 1 minus x 1 plus x square. What do we do? A upon 1 minus x plus, this is the quadratic term which we cannot factorize further, so that will be written as a. So next will be bx plus c divided by 1 plus x square. So now our job is to simplify this. It's also quite simple only. Okay, so 2 divide upon, okay, if you want to take the LCM, just not to get, yeah, 1 minus confused, 1 plus x square equal to LCM 1 minus x 1 plus x square a into 1 plus x square plus bx plus c 1 minus x. So this one is better, it's better to simplify a plus a x square, not like that previous term, because here we have same terms where we just cannot simplify completely. Minus bx square plus c minus cx. All right, so here it's always, you know, that method of simplification where we, what do we do? Yeah, putting x equal to 1. This is only possible when, much more applicable when the terms are non-repeating terms. When we don't have the same terms. So but here we will have the same term, so here better to simplify it, compare the coefficients and find out the values of the constants. So grouping them, ax square, so a minus b x square plus b minus cx plus a plus c, equation 2. All right, so now I'll move on to another page, that will be better. So what do we do now? Comparing the coefficients. Okay, so on comparing the coefficients of x square, x and constant term on both sides, we have, so what do we have? The constant x square 0, x term 0, constant term 2. So we can write it as a minus b as 0. So from there we can have a equal to b. The other term b minus c also equal to 0, so that is b equal to c. And a plus c is equal to 2. Right, a minus b equal to 0, b minus c equal to 0, a plus c equal to 2. All right, okay, so now let's solve this, find out the values of a, b and c. So how do we solve this? Okay, so far we have written equation 2. If you want, you can mark it as equation 3 and equation 4. So a value is c, the value, okay. So what we can do here is, see, a is equal to b and b is equal to c. That means a is equal to c. So here value a I can use as c. So since this is already mentioned here, no need to write anything. So 2c equal to 2. So c equal to 1. Therefore, from equation 4, what would do we have? B is equal to c, that is also 1. And from equation 5, a is equal to b and b is equal to 1. So the values of a, b and c are all 1. Okay, so putting the value of a, b and c, if you want to write, I mean, in equation 1. So what will be equation 1? That's going to be 2 by 1 minus x, 1 plus x square can be written as a value is 1. So 1 upon 1 minus x plus b value is 1 x plus c divided by 1 plus x square. So now when we go for integration, therefore the value of I will be integral of 1 by 1 minus x plus 1 plus divided by 1 plus x square. So integral of this value. So that's going to be integral of 1 by 1 minus x with respect to x plus integral of x plus 1. So this one also we can factorize, 1 plus x square plus 1 by 1 plus x square. Common LCM, 1 plus x square. So x by 1 plus x square, 1 plus 1 by 1 plus x square. So further simplifying this, 1 minus x with respect to x plus integral of x by 1 plus x square with respect to x plus integral of 1 by 1 plus x square with respect to x. So here, before we, no need to apply substitution, directly we can do, isn't it? So I'll just multiply and divide by 2, then problem is solved. Because if you remember, I had given you one formula again, that is integration of, if you have in the denominator a function and the numerator you have its derivative, then what do we have? That's nothing but log of f of x, the function. So if we see here, what is the function here? F of x is 1 plus x square and its derivative is 2x. So just multiplying and dividing by 2, this picture is complete. So now we can solve. That can be written as log of 1 minus x plus 1 by 2 log of the function. So that's 1 plus x square plus this is tan inverse of x plus c. So I think you can sorry, this one 1 minus x, we forgot one term. So again, by substitution, if you remember, I had told you that just divide it by the coefficient of x if it is not positive or if it has some other values. Here we see that it's minus 1. As long as it is plus x, no need to use substitution, 2 plus x, 3 plus x, whatever be that. Our main concern is the coefficient in the variable here. So but if you have a coefficient along with the variable, then whatever value you find out after integration, you divide that by the coefficient 5. So here what do we have here? Minus 1. So after getting the integral, we divide it by its coefficient of x, that is minus 1. If you use substitution method, you're going to get the same value. So this is just the direct method actually, without using substitution. In previous videos, I have already told you about this, just a reminder again. Bus, that's it. All right, so that's your solution. Okay, so that's up to question number 13. All right, so fine then. So that's where we will wind up for now. In the next video, we'll try to solve again 4 or 5 questions. All right, so kindly note this down, study well, all the best. See you in the next video. Bye bye.